In this next video, video 6.4, our learning target will be to understand how to use the formula for finding circumference and area of circles. Our essential question in this video is, when might you need to find the area and or circumference of a circle? Think about a real-world application as to when you might need that. Our math practice standards for this video or for this lesson are 1, 3, 4, and 5. We have lots of key terms, but we're going to do it in two different ways. There are three that I want you to write down. And the first one is area. And we've talked about area before, but the area in when we're dealing with circles is, again, the measurement inside the circle. And I know we've used squares to talk about how many squares would fill up a polygon. We would do the same thing with a circle. Circumference, that is the distance around a circle. It is the perimeter form for circles. So you could think of those as just being interchanged. And then pi, that is a ratio, and remember we said ratios could be like a fraction, of the circumference of a circle to the length of its diameter. All right. The second way we're going to go about completing our vocabulary is we're going to take a diagram of the circle, so draw one of those, and then you'll see that I have put in some drawings, and we need to identify them and label them. The top drawing here you will find is a chord. And a chord is nothing more than a line segment that will touch two sides or two parts of the circle, but it does not have to go through the center. It could, but it does not have to. Now, the next part we're going to identify is this long piece here, this all the way across the center of the circle. That is the diameter. This piece here, which is half of this length, is our radius. Now, in going back and talking about a chord, look at a diameter. A diameter touches two sides of the circle, or 2 points on the circle, and it does go all the way through the center, but it doesn't have, well, the diameter does, but a chord doesn't. A diameter is also considered a chord. It's actually the longest chord in a circle. Radius is obviously half of the diameter. This point here in the middle, that is the center. And a center is how we name a circle. If this happened to be an A at that point, then we would call that circle A. Pi, as we talked about in the definition, uses this symbol. And it is typically used as 3.14 or the fraction form 22/7. Now, moving over here, we are going to talk about circumference formulas for circles. Now, there are two of those. The reason is sometimes in a circle you'll be given the radius, which is half. Sometimes you're given the diameter. Depending on what you're given, you can choose to use one of these two formulas. The circumference of a circle, which is represented by C, is equal to 2 times pi, which we know is 3.14 or the 22/7, times r, and r is equal to the radius. The other form we can use is C is equal to pi times d. And in this problem, d is the diameter. Everything usually takes on the first letter of the word. Area, and I've actually talked to you a little bit about this in class before. Area is equal to pi r squared. And r is the radius. And you do have to follow order of operations when you are working in the area formula. All right, we're going to look at 3 examples, and we're going to start with an example where we're going to do some approximations, and we're actually going to approximate prior to doing the problem. In this first example, the diameter of a jar lid is 6 centimeters. What is the approximate area of the top of the lid? Notice over here I've drawn a diagram. I have figured out everything I know in this problem. Here is my circle for the lid. It is a diameter of 6 centimeters. Diameter goes all the way across. I know I'm working with approximate, and typically when we are asked to approximate something, we are actually approximating pi, making that a little easier, maybe not in a decimal format. So I'm just going to say it's approximately equal to 3 if I round to the nearest whole number. Okay, now I know that the area formula requires me to use r, the radius. So I have taken the diameter and I have divided it in half to find the radius. Now I have all the information I need to complete my problem. The area is going to be equal to 3, which was our approximation for pi, times the radius, which we also know to be 3 squared. Remember I said you have to follow order of operations. So we would do the 3 squared first. 3 squared is 9. And then we would multiply that by the rest of the information in our problem, and we would have the area is equal to 3 times 9, which is 27. Now we're dealing in area. I also have to have my units. My units are centimeters. And again, even though I am working with circles, my areas are also squared. Come down to example 2. Example 2 is a little more basic. We're looking for just the circumference, and I've given you the value to use for pi, 3.14. Now, the formula I have chosen to use, and I did this prior to starting the video, I chose to use pi times d because in my diagram, I know that the diameter is 3. So that you can see it all, we're going to just do sideways here. We have 3 14/100 times 3, which is our diameter. If I multiply these two together, my circumference ends up being 9 42/100. Again, we're in centimeters. And since we're only finding circumference, which is the same as perimeter, we do not need to square it. We just leave it in centimeters. Moving on to our last example. Our last example is going to require us to do a little algebra and work backwards. If the area of a circle is 296 hundredths meters squared, what's its diameter? Excuse me, I'm getting tongue-tied. What I have done is I have written down everything I'm going to need to know in this problem in order to figure it out. They told me the area. I'm asked for the diameter in the problem. And since I'm working in area, I know that the radius is probably going to be part of the problem. Pi, we're going to use 3.14. So I've come over here and I've already started setting up the problem for you. Area is equal to pi times the radius squared. I have filled in 296 hundredths is my area form. That is equal to pi times my radius squared. But I have to figure out what my radius is. So I'm going to work backwards a little bit. And I am going to divide by 3 14/100 on either side. Those will reduce to 1. That leaves me with r squared being equal to, and just through the magic of calculators and working this out ahead of time, I know that the answer to this division problem is 64. Now, we haven't really talked, excuse me, move the camera. Sorry about that. We have not talked much about square roots and finding them. Now, we've talked about squaring numbers, but not taking the square roots. So what I want you to think about is 64 is equal to r times r, where r is going to be the exact same number. If I think of it in these terms, I know that the number that needs to go in both of these r's is 8. So if r is equal to 8, I can come right over here and make sure that you guys can see it since I move things around a little bit. R is equal to 8, but I still have not answered the question that is being asked. The problem says, what's its diameter? If you know the radius of a circle, the way you find the diameter is you double the radius. So if I say the diameter is equal to the radius times 2, then that would be 8 times 2, which gives me 16. So the diameter of my circle is 16. Now, units, we always need to make sure the units are there. And since we are dealing in meters, the area was meters squared, but that just meant that each of the units for each of the pieces was in meters.